Okay, we've been solving equations. We're going to take it up a notch and work on solving absolute value equations. This kind of takes it from Algebra 1 to Algebra 2. This is more of an Algebra 2 topic because it's a little more advanced. Now, I do have a four-step process here that I'd like for you to write down. First step is you isolate. Isolate the absolute value part of the equation to one side, if it's necessary. Sometimes it's already done, and we'll see examples where it's already done, and we'll see examples where we have to do the isolating in our video here. The second part is to split the equation into two parts. And it's really a positive part and a negative part. And what I want you to see here is, the question is why. If I were to take the absolute value of 2, well, let me do this. Let's put a variable here. The absolute value of x is equal to 2. Well, what numbers can I put in for 2? Well, the absolute value of 2 is equal to 2, so x could equal 2, and the absolute value of negative 2 is also equal to 2. So x could be negative 2. So we split it into two equations because the absolute value of positive is positive, and the absolute value of the opposite, the negative, is also positive. So this has two solutions. That's why we would split it into two equations, one with positive and one with negative. You then solve both equations. And here's a very important step. You know, sometimes I always thought this is just busy work, checking your solutions. This is necessary work in absolute value, because sometimes you will solve using correct procedures and everything, not make any mistakes, and one of your solutions or both of your solutions may be extraneous, which means it doesn't work. Something happened in the absolute value part that would make it not work. So check your solutions, keep the ones that check out, and discard the ones that do not, or call them extraneous. So, example 1, isolate the absolute value. Absolute value of y plus 5 equals 8. It is isolated already. You got an absolute value expression on the left side of the equation. So now we're going to split into two equations. Y plus 5 equals 8. Then I put the word or in between them. Y plus 5 equals negative 8. So you split it into a positive side and into a negative side. And then we solve each part. I'm going to subtract 5 from both sides of this equation and have y equals 3. I'm going to subtract 5 from both sides of this equation, and I have y equals negative 13. Now I'm going to check. And you check in your original equation. Does the absolute value of 3 plus 5 equal 8? Well, this is the absolute value of 8. Does that equal 8? And the answer is yes, it does. So I'm going to circle y equals 3. Now I'm going to check negative 13. Does the absolute value of negative 13 plus 5, I'm putting negative 13 where the y was, does that equal, I'll put a question mark over the equal here, does that equal 8? Negative 13 plus 5 is negative 8. Does that equal 8? The absolute value of negative 8 is 8. 8 does equal 8, so that checks out. So those are our two solutions. They both work. All right, example 2. Isolate the absolute value. Here we do need to isolate the absolute value. I'm going to subtract 8 from both sides. I have the absolute value of 4b plus 1 equals negative 5. Now, I am going, let me make that one a little easier to see. I'm going to split into two equations. 4b, and when I split into equations, I'm removing the absolute value. And I don't think I mentioned that. I did it, but I didn't mention it in this example. When I split on the split step, the absolute value bars come out. They're gone. We solve it without them. So I have 4b plus 1 equals negative 5, or 4b plus 1 equals 5. I'm going to subtract 1 from both sides. I have 4b equals negative 6. Make sure to tell the difference between my b's and my 6's. Divide by 4. I think if you do that, you'll get b equals negative 1.5. Now I'm going to subtract 1 from both sides here, and I get 4b equals 4. Divide by 4, and I get my other answer, b equals 1. Now the checking part. Let's check negative 1.5. The absolute, and I'm checking in this, the very original when I check. The absolute value of 4 times negative 1.5 plus 1, and then add 8 to that, will equal 3. Well, 4 times negative 1.5 is negative 6. Negative 6 plus 1. Absolute value of negative 6 plus 1 plus 8. Does that equal 3? Well, this is the absolute value of negative 5 plus 8 equals 3. Absolute value of negative 5 is 5. Does 5 plus 8 equal 3? Answer is no. 5 plus 8 is 13. So this solution here is extraneous and doesn't work. Now, let me check the b equals 1. The absolute value of 4 times 1 plus 1, oops, not a, it's an absolute value, not a curved bracket. Let me put a 1 right in there. Plus 8. Is that one equaling 3? 4 times 1 is 5. 5 plus 1 is 5. 4 plus 1 is 5. Absolute value of 5 plus 8. Does that equal 3? Well, absolute value of 5 is 5. Is 5 plus 8? We already decided that that was not equal to 3. So that one does not work. This equation has no solution. That's why it's necessary to check. All right, let's look at this one last one. I'm going to isolate this absolute value. So I'm going to add x here and add x here. Do the same to both sides. I want to get rid of that minus x, so that's how I'm doing it. Absolute value of 2x, 2 times the absolute value of x plus 1 equals 3x plus 1x, which is 4x minus 4. Now, here's the tricky part here. I got to divide by 2 because I need to have just the absolute value there. So I'm going to divide this one by 2. Those cancel. I got the absolute value of x plus 1 equals, and when you have 2 underneath an expression like this with 2 different parts, you can divide each one by 2. 4x divided by 2 is 2x. 4 divided by 2 is 2. Absolute value of x plus 1 equals 2x minus 2. So there's the isolating. Isolate, split. You got a positive and you have a negative. So this first one is x plus 1 equals 2x minus 2. Just leave it like it is. Or x plus 1 equals, and with the negative we go exactly opposite. negative 2x, but a negative and negative 2, that's positive 2. So I have my two equations to solve now. I'm going to get the x's on one side, so solving for x, those cancel. That's 1 equals x minus 2. I will add 2 to both sides. I have 3 equals x. You need to check that. And on this one, I'm going to add 2x to both sides. I don't have to deal with a negative x then. X plus 2x is 3x plus 1. Those cancel, equals 2. Let's subtract 1 from both sides. I have 3x equals 1. And then when I divide by 3, x is 1/3. All right, it is time to check in our original problem. 2 times, this is the checking part. I'm checking 3. Check 3. So 3 plus 1 minus 3 equals 3 times 3 minus 4. Everywhere there was an x, I'll highlight it in red here, I put a 3 everywhere in this original equation. So 2 times the absolute value of 4 minus 3. Does that equal? 3 times 3 is 9 minus 4. Put a question mark over that because I'm not sure yet. Absolute value of 4 is 4. So 2 times 4 minus 3. Does that equal 9 minus 4? Still checking. 2 times 4 is 8. 8 minus 3. Does that equal 9 minus 4? I think so. This is 5, and this is 5. So, x equals 3 is a solution. Now let's check 1/3. Let's check when x is 1/3. So 2 times the absolute value of 1/3 plus 1 minus 1/3, does that equal 3 times 1/3 minus 4? Well, one third plus 1. 1 is 3 over 3. And minus the third. 3 times a third, that is 1. 1 minus 4. Okay, so what do I have here? I have 2 times the absolute value of 4/3. 1 plus 3, and keep the same denominator when you're adding fractions. Minus 1/3. And 1 minus 4, I'll put these question marks, I didn't do that at the beginning. I'm wondering if this is going to equal negative 3. Well, the absolute value of 4 over 3 is 4/3. It's positive. Minus 1/3. Is that going to equal negative 3? 2 times 4/3. That's 2 over 1. 1 times 3. That's 8 over 3 minus 1 over 3 equaling negative 3. Well, I'm going to say no, because 8/3 minus 1/3 is 7/3, and it's positive, so there's no way that's negative 3. So that one does not work. This is an extraneous solution, so this one only has one solution. X equals 3. Example 3 is a case where we checked, and one of them worked and one of them didn't. That's why we checked. Example 2, neither of the solutions work. Example 1, wherever I had that, is right here. Both of the solutions worked. So just keep that in mind as you go through this. All right, take care.